Alright, so in this session we're going to be talking about some common recommendations from NI code reviews. So these are going to be recommendations based on common themes that Eric and I have found as we walk through different reviews that NI has done in the past. So my name is Burghart. I'm an application engineering specialist here at NI.
And I'm Levy, staff application engineering specialist.
Alright, so just a quick overview of what we're going to cover today. I'm going to go through our process for doing code reviews, sort of at a high level. So I'll show you what our template looks like, how we rate different issues that we come across, and why we did this exercise in the first place. And then after that, we're going to step through a few examples of issues that we've actually found. Just a disclaimer, the code snippets that we show are not from actual customer code. These were inspired by customer code and themes that we've seen. And they're also not perfect. The solutions are not perfect. It's just meant to show at a high level some things that we see frequently and then how you might be able to address them and educate your developers so that their code next time around will be better. So what are these examples based on? Periodically, applications and systems engineering at NI does do code reviews for some of our customers. These can happen in a few different situations, one being when we have a support issue on a large code base. So if we have an application that's really large and not something that you can just look at and understand in a few minutes, we may do a full code review so that we can take a look at the whole application and then look for any issues within it. Second, when we have a customer who has concerns about style, performance, or best practices, we can evaluate their application and sort of give them some pointers and say, okay, here you are adhering to our best practice, but in this area of your code, maybe you want to make some changes. And finally, when we have a functioning application, so one that isn't experiencing any issues, but again, they just want validation of best practices, maybe it's an internal Git review and they just want someone to double check. So here's a look at what our template looks like for NI code reviews. It's not anything super crazy. We have a pretty basic cover page and then a few topics within it. So we cover the purpose and intent of the review. So why are we doing this code review in the first place? What are we looking for? Are we not looking for anything particular? A brief summary of the application. So what is the application designed to do? How is it intended to function? What types of code can be found within it? So is this a real-time or an FPGA application as opposed to just a LabVIEW application? And we may also recommend some training. So an example there would be if the developer who wrote this code is brand new to LabVIEW real-time and this was their first shot at it, we might recommend that they take embedded control and monitoring so that they can fill in their knowledge gaps and just develop better code going forward. And then after that, we get into the meat of the review. We review separately the code architecture or design pattern, the LabVIEW code, any LabVIEW real-time code, and any LabVIEW FPGA code. So then within each of those sections, we classify issues with a severity. So red issues are things that will absolutely be a problem. These could be things like no error handling whatsoever. So these are things that need to be definitely addressed in the application going forward. A yellow issue is something that may be an issue and poses concerns for the longevity of the application. A white issue is something that may not be a problem long term, but it could be a best practice or a matter of efficiency. Optimizations are just things that the reviewer notes, like in this piece of code you could change your timing or tweak this and you'd see better performance. And then any additional references that we may recommend for the developer to review. So that could be something like the Compact Rio Developer's Guide. So, and finally, what can we learn from code reviews? So Eric and I went through, I think, about 20 or 30 different reviews that our group has given over the years and sort of looked for the themes. What are we recommending time and time again? What do we want our developers to be learning going forward so that they're not making the same mistakes over and over? And we also wanted to address how can you help educate your developers. So not just how do you fix an issue where somebody uses a time loop improperly. Most of you guys probably know how to do that already. What we want to look at is how can we educate our developers so that next time they already know how to use that time loop correctly, and we don't see them making the same mistakes again. So there's 4 main categories that we'd like to cover. One is dividing tasks. So how do we divide tasks between loops? Data transfer practices, loop timing, and error handling. And then we'll cover some sort of additional issues that didn't fit into a major category at the end. So our first dividing tasks example. So this code is typical of a newer developer. The tasks appear to be in parallel, but they're all within the same loop, and they're going to have to wait on other tasks to complete. So we have some network communication, digital output, array manipulation, analog input, data interpolation, and file logging. So again, the actual code is not what's important here. What's important is that we have all of these tasks happening in a single while loop in this customer's application. So this code might work well when tested, just sort of a quick, oh, hey, look, it runs, there's no errors. But this code isn't going to work well in the long term. So one thing we can do is remind our developer that LabVIEW is a great environment to take advantage of parallelism and show them how to do that. Someone coming from a C programming background or a Java programming background might not realize this about LabVIEW, especially if they're new. So here we split all of those tasks into 3 parallel loops so that our digital output isn't dependent on file logging or network communication. Showing a developer an example of this, even if it's just splitting up one loop quickly and saying, hey, look at how you can run all these loops in parallel, that can help teach them for the next time, and it can give them something to work from when they go through and correct the rest of their application, especially if it's larger in nature. So, and this is just a similar example of a real-time application. In this case, our developers used a time loop, and again has put network communication, file logging, analog input all in one loop, which isn't generally going to be good practice to begin with, but when you add a real-time application into the mix, you're losing any advantage of that time loop. You're not going to have a deterministic application. So again, a great way to address this with your developer is just show them an example. Show them how they can take advantage of parallelism. Show them when that time loop should be used and when you should just be using while loop with timing. So demonstrating these concepts with an example or just by walking them through some of the steps can really help them to make these changes themselves. So just some general recommendations. Keep loops focused on specific tasks. Help them learn what is determinism. Maybe they don't know the difference between a deterministic or not deterministic application. So this will help them in the long term with their development. So next I want to take a look at a couple of data transfer examples. So we have some code that's just acquiring 16 digital input channels. This looks like it might have been written by someone who's familiar with ladder logic. So again, a developer who's not new to developing, but maybe new to LabVIEW. So, all right, now we see that maybe they're more comfortable using local variables and wires. Again, something that we see all the time. Now here, they've continued to expand their code. And the state that we're in, this is going to be really difficult to fix later on, especially if it turns out that there is a bug. So, all right, now we've added a while loop into the mix. This isn't too bad as long as we aren't writing to those local variables in multiple places. This is kind of bad. So now not only are we relying on local variables in places wires, but we're writing in multiple places. And again, this is something that we see all the time, maybe not this explicitly, but this is a theme that comes up again and again. So how can we help our developer resolve these issues and learn going forward? Teach them about wires in place of local variables. This is a great example where we can talk about data flow and what data flow looks like in LabVIEW. Sequence structures do have their place, but they can be challenging for newer developers to use appropriately. They look like a really great idea, but I'm sure we've all seen someone who's brand new to LabVIEW overuse them to a fault. So same thing with local variables. They have their place, but they're not appropriate in every situation. And like I talked about before with the loop timing the parallelism examples, demonstrating this, even just taking a quick snippet of the customer's code or the developer's code and rewriting it for them can go a long way in showing them, oh, this is what my code could look like. How do I apply these concepts elsewhere in my application? So, and a second example under the topic of data transfer is the overuse of functional global variables. This is, again, something that we see really frequently. So in this case, we have basically a get-set architecture. We have two while loops. One is setting data into a functional global variable, and one is getting the data. And what can happen in this case when those loops are at different rates, this was just the screenshot I took when I ran this VI, is that we can see the writer loop writing multiple times before we're getting the data. So one thing that newer developers may not understand is that while functional global variables do protect your data from being written to and read from at the same time, it doesn't prevent a race condition. So how can we help our developer move past this and learn to better develop their application? One way is to introduce them to different methods of data transfer. If you're brand new to LabVIEW, functional global variables are a complicated concept and can be difficult to grasp. So instead of that, channel wires, which are new in LabVIEW 2016, really visually show where the data is going. So if you have a developer who's just learning about data flow and how to understand it, this is a great way for them to wrap their head around it before they move on to a more advanced architecture. And just some final thoughts on data transfer. Work with your developers to look at all of the relevant methods of data transfer in your application. Functional global variables are not always the right answer, nor are local variables, nor are queues. There's a lot of different ways to transfer data, and it's important to evaluate all of those options before selecting one. Sure. Yeah, I think so.
There's plenty of examples where we did it.
Yeah. We can revisit that at the end of the Okay. So I'm going to pass it over to Eric, who's going to talk through the rest of our examples.
So we talked briefly about separating tasks and what the benefits of that are, and how that's something that some developers kind of get some bad habits in. Another topic similar to that is loop timing. And so a lot of these examples we've shown, I think, are cases where maybe people never established a best practice or never really saw where their code and practices became problematic. And that's something we see a lot during our code reviews. Code that simply just worked in its current form and was moved on from. So when we review code, we always like to show off what the best practice is and how what their customer is doing can be moved toward that best practice. So the next topic here is about loop timing. Here's a couple of examples, 3 examples even, of where loop timing is used weirdly or incorrectly. So this first one here, people like timed loops. They look good, they appear to give a lot more control over the timing of a loop. That's usually true on real time and not generally true on Windows. So really here, say this is a Windows application, there's no real need for the timed loop. Another example here is a loop that doesn't really have timing. There's no timeout or anything here. In this case, if this was running on Windows, we'd see that it would probably just be limited by the core it's running on. And might just work fine from someone who's not really paying attention to that. Say we were to move this to, say, LabVIEW real-time, all of a sudden we might have this loop railing a processor and having the controller drop off the network. So here we have a loop with no timing. And then lastly, this one's a bit of an interesting example. We have a situation where we're using two different forms of priority. This last loop here is using VI priority and loop priority. And we might typically see this in someone that has been programming for an experienced developer who's not really used loop priority before. Or an example of an old API that uses VI priority mixed in and being trying to brought into LabVIEW real-time or something like that. So here we have mixing loop priority and sub-VI priority. So how do we go about fixing some of these things? Well, so we've seen these issues here that from our code reviews that we've been through are fairly common. Not quite understanding what timing a loop does or how a timed loop works or where you would not need one or not. So the solution here is once again sort of just showing that you don't need a time loop, especially on Windows where you don't get a lot of the benefits. The extra overhead, explaining how that works. It's not always clear, especially to a newer developer, that the little timing VIs we have pretty much perform the same functions in a lot of ways. So in this case, what we've done is we've simply added in our own timing and removed the time loop in the first one. In our second one here, we once again just added our own timing. The last one here, we've just moved everything to VI priority. It's best when it comes to priority not to mix up two schedulers. People prefer, I tend to prefer not using VI priority because it's a little hard to self-document, but I know people have their preferences, so being sure not to mix the two is important. So here, this is a bit of a mess, and this is something that we have seen before, mixing multiple timing methods. So here we've got a time loop with an event structure and our own little timing block here. And this might, the customer might look at this and think that it behaves the way they think it will, and indeed it will not. So showing where we can find opportunities to time more simply and avoid situations where a loop's going to behave a way a customer doesn't think it will is important. So yeah, here, this loop is not going to work the way they think it will. So the solution here is encourage developers to be consistent with their timing strategy throughout their application. Utilize design patterns here, such as producer-consumer, divide up tasks between loops efficiently, and efficiently use efficiently use computer resources. So this one in particular is actually very similar to real customer code we've seen. I want to point this out because that seems really silly, but indeed that is real, based on something real. So general recommendations about timing. Use VI and loop priority only when necessary for deterministic tasks. Use a clear and consistent method for controlling the loop timing. And to a certain extent, don't overthink it. A simple timing VI, wait until millisecond multiple or wait millisecond, you generally will work fine for many, many kinds of tasks. Newer developers might find it helpful to have additional description of what a deterministic task is, or maybe it did help showing this in particular, your deterministic task. Timing is very important, and then kind of letting them work the remaining tasks. So now we're going to talk about error handling. And this one I'm going to preface with, error handling is obviously important, and not a lot of developers miss that. But we do have situations where a developer may overlook it or not consider it as important. So these examples are a little bit hyperbolic, but are reminiscent of things we've actually seen. So in all three of these quick examples here, there is something very, very much missing, and that is any form of error handling. There are three situations where error handling can be missed and be problematic. And so those situations are code that needs error handling to function correctly. So this one here is based on an example, a TCP multiple connection manager. We need the errors here to change the code path to either remove or add a TCP listener. The next one here is just a DACMX task. We need to check errors here, obviously, because there could be bad data coming in or a problem on our hardware. And then lastly here we have soft motion, where we're performing a motor move, which could become dangerous if there's an error we're not monitoring. So once again, it's pretty crazy to think that maybe there would be errors handled just simply removed from this. But when we work with developers who might be working quickly or trying to rapidly prototype something, there are situations where they may overlook it, just see it and perform as what they expect it to, and not give it a second thought. So that's behavior we need to remove, a habit that would be pretty problematic. So what to do here? Well, there's many ways to do error handling, but typically the things we're looking for are either logging the error, reporting it to a UI, changing the code path based on an error. So like I said, I think it's really obvious here that errors are going to need handling. That's not something that's groundbreaking at all. But there are times when an inexperienced developer might think, oh, you know what, there's really nothing that could happen from this code, which is, you can't account for everything. Or someone might say, you know what, I didn't run into any errors while testing, so I didn't add anything. That's something I have heard from a developer before. Or more likely, yeah, I wrote this code really fast, didn't see any issues, just moved on to the next thing. So in our code reviews, we typically recommend adopting an actual framework for error handling. And the one we often recommend is the structured error handler, which is a library available from our systems engineering group. So having an organized framework, something that's planned out, that's not something that all developers come up with immediately. So other problems with error handling is error handling that exists but doesn't really do anything. This one I think is a little bit more common in that situation where we have error wires and we have them end up in a control or indicator, or excuse me, an indicator. People will kind of do this, they'll do their testing, see that it's not giving any errors, and then move on. But during application, during runtime, this doesn't really do anything. So this is an example of error handling that is ineffective. So in this case, in the event of an error, the while loop continues to run, which is going to be problematic. So the solution here is make use of error wires such that it's actually changing what the code does. Showing a customer that there are situations where just being aware there's an error is problematic. We need to stop the loop. We need to have some other kind of function run. So this is still, once again, very, very basic and very obvious, but when it comes to a specific person's application, it might not necessarily be something they've already thought of. So here we have our error case structures. So some general recommendations for error handling. If something is safety critical, the customer is absolutely interested in making sure that the errors are handled in such a way that nothing can go wrong. So showing examples, once again, of an error handling framework or other larger applications, how they've made use of error handling can be very helpful. I think coming up with a framework for error handling can be very daunting for customers, especially people who haven't architected a system before or worked with a larger program. So showing those off and giving examples can be really, really helpful and something we do in our code reviews. So now that we've covered sort of the four biggest pillars that we found from our code reviews, we're going to briefly talk about some of the little issues that we see very commonly but didn't really have space to fit into our presentation here. Big one, array manipulation. Changing the order, shape, or whatever with an array, and there's many, many ways to do it, and we typically see inefficient or bulky or hard to read ways of doing this. Situations that might benefit from redoing the code or perhaps using some of the OpenG array functions. Overuse of sequence structures. We tend to see newer developers who've used other languages like ladder logic or PLC programming overuse these and kind of tailor their program to what can fit in a frame of a sequence structure or what looks good in a sequence structure. So while that doesn't necessarily change the functionality of a program or make it worse, it's not good and it's not a way to sort of encourage the data flow language that is LabVIEW. So we try to address those when possible. Lack of optimization, code that's inefficient, code that's going to slow their program down, or some code that might cause a memory leak or be something that would be something to look into in the event of a memory leak. These are common things that we see that we have sort of quick examples to help with during a code review. Unnecessary code we see a lot, code that was vestigial, something that did something in the past that's still in there that can just be removed. When you have an application that's large and not a lot of people keep track of it, this is something we run into. Lack of documentation could probably have been its own presentation in that we always see it. Whenever we do a code review, there's almost never enough documentation. So it's one thing that we always like to drive home and bring up during a code review. Another thing we don't see that often is lack of documentation. We always run into this. Customers don't always realize just how vitally important documentation is. And then last thing we'll talk about today, absolutely the most important thing we run into is lack of documentation. It's really hard, we found, to express just how important it is for us as supporters of code, doing a code review, anyone else who will see it again, just why that much documentation needs to be in it. So when we run into a situation where there's no or very little or ineffective documentation, we like to show off some examples that we've made that we feel are well documented, and that's been helpful as well. So that's sort of just a quick run through, guys, of what our code reviews we've run into, what we typically see, and then how we like to address them. So here we are at the end. I'd like to open it up for questions. Yes?
That structured error handler, is that just a package?
Yeah, so it's one of our reference libraries that you can get, I believe, from VIPM or from our website. So.
Could you please repeat the question?
Oh, I'm sorry. The question was the structured error handler, or SEH. What is that and how to get it? It's a sort of adaptable error handler with sort of configuration-based, where you can have a quick little VI actually sort of route errors easier. It's a great way to start for an error handling framework. It's not always perfect for every application. We often see people making their own error handling framework, but it's a good starting place, especially for someone that's new to that.
I mean, a lot of this is really good to know for, like, common errors to look out for programming developers. But when you're working with, let's say, more experienced developers or significantly larger code bases, a lot of these things, like, you don't end up seeing.
I would first say that you'd be surprised, but continue.
No, but I'm saying, like, when you're working with, like, let's say, a bunch of CLDs and CLAs, usually they know to do error handling. You may find some instances. Do we have any recommended, I guess, code review structures to go by structure? I mean, like, kind of like a framework people should do. Obviously, this, but like, how do you go through, let's say, a large application? Obviously, let's say you have 10,000 VIs, you can't just do it for every single VI in there. But I guess, do we have recommended practices for that, or which things do we offload onto, let's say, VI Analyzer, and which things do you actually have like a code review for, and like what is like process for, let's say, the meetings that are in code review?
So I think, do people, partners, for example, that do code reviews, if they're going to have their own processes? I don't think we as NI recommend a general one, but we and our applications and systems engineering, we do have a process for that. And typically what it involves with is figuring out what is the purpose of the code review. In the first slide we said there's usually like 3 examples, and the one we get the most often is there's something going wrong in this massive code base. And this, when we get these, it's typically what I would describe as an intermediate developer. Someone who is not immune to these problems, but knows enough that we can point them out and they'll be able to fix them themselves. Or a situation where there are some middling experienced developers working together but not necessarily communicating that well. So in that scenario, what we typically do is try to figure out in general what is going wrong with the code, have lots of discussions about them, talk about which piece of code we think are the most at risk, and focus on them anyway. At which point we do have some VI Analyzer. I don't think it's anything internal, just sort of general tests that we do that will either let us to think, what, this section of code is probably fine, we don't need to get into it. So it kind of depends on the situation for us in particular, but we do have sort of a really, it's hone in on what is the purpose of the review and focus on areas we think that apply to that.
I think it's just piece of feedback that we go through, and I don't know if this is something that can show up in a white paper, like what is the process? Because I would assume there's a lot of best practices.
I think we would probably want to think about that, but we also don't want it to necessarily be the recommended, because there are tons of different ways to do this. So, yeah. So the purpose of this presentation was more about here's a peek of what we're doing, rather than here's how we think you should do this. Yes.
So I'd like to disagree with the statement made here that you cannot review an application made 10,000 years. And I don't have experience with 10,000 VIs and such, but I do have experience with thousands, where every single one of them was reviewed. And it can be done, and when one is working with such scale, that is precisely the time when it should be reviewed. And it is, yes, I will agree that it's impossible to do that after the fact in an effective way.
Yeah, that's what
But that type of project should be set up with a review process up front, and then things need to be reviewed in small chunks and often and starting early.
Yeah, and typically when we're brought in,
You were 10,000.
So I agree that doing it after the fact is hard, but not doing it during the process is also really hard and will cause undue pain to participants.
and now typically when we're brought in as application engineering specialists for one of these reviews, it's largely because periodic reviews like you're describing are not happening at this developer site. So we kind of get some of the worst when it comes to these.
Oh, I totally get it. And that's why I was saying, like, understanding, like, best practices for, like, how and when and what to look for
Yep.
during these periodic code reviews, so you don't ever have to tackle,
Right.
you know, the monster bear at the end of it.
Yeah, changing habits is not oh man, I had this one code review document, now my life has changed, I'm a good programmer. It's a gradual thing. So that's, yeah, periodic code reviews are absolutely vital to having good code in the long run. I've got a question.
Is there a certain threshold where you look at a code and say this is a complex enough application or a small enough application where you want to do this whole code review process versus say an email, a visit, call?
Yeah. Yeah, so I'll give you an example that I'm going to be kind of scrubbing for details here, but we had a customer with a pretty major problem that seemed to be related to one of our drivers. And we decided that we wanted to get in, we wanted to support this problem, and I got brought into this. And we found pretty quickly that in order for us to tell whether this is really the driver's problem or the fact that, or like a programming issue, like some sort of flow problem with the application, we couldn't tell. The code was in such a tremendously bad state that data transfer one with all the local variables ripped, inspired by this story. It was in such a bad state there was no possible way for us to support the problem without them making some code improvements first for us to actually understand the code. So we got brought in and did a very in-depth code review because the risk of us sort of missing something and just doing a quick review that might be, hey, we found this, here's an email, was such that we needed to address the whole thing. So it was probably the largest code review I've ever done, and they made lots and lots of the changes, and at which point we found that it was easier for us to troubleshoot. This is one that had incredibly little error handling, so it was kind of a crapshoot trying to figure out in the first place. So once they made a lot of the changes, which being that they were so numerous, it took a while, but at that point we were able to quickly pinpoint and realize that it wasn't our driver, it was actually a situation where there was a race condition in their code, and we were able to fix it. So another thing we run into is sometimes code reviews can shake the problem out or even fix it.
What about on the smaller end? Can you say, like, hey, I can open this up in an hour and kind of look through it and do something like that? And do you think it's necessary at those points to do when you are seeing a lot of these regular, inexperienced developer issues? Would you do that formally and list through this process?
Well, so the great thing about the process is that it enables us to show examples of how to fix things like we were showing you in this presentation. So when it's something that we think that we can change a development habit for a customer, we do like to do it. If it's something very small, it would depend on the customer what they're looking for. If they're looking for best practices, it might be best for us to make a sort of smaller document like this where we detail things out, show them the red issues, yellow issues, white issues. But if it's a really small code base and they're asking for specific questions, then it's probably not necessary. I think it really depends on what the customer's looking for. Are they looking for something holistic or something to answer a specific question? Yes?
What's the level of code review? For instance, React web code needs to run for 4 months at a time. You looked at it, run that definition of file.
So the question was sort of what's the scope of a code review like if it were to... So the code reviews that we do, we tend to prefer it not to hinge on functionality alone. Like, what we'll do is search for optimization, search for areas we think the code could break down or experience problems. But when it comes to the runtime of the code, we don't always, we prefer to let the customer kind of tell us when it's running correctly or not. So an example would be maybe we had something that's supposed to run for 4 months, and we're finding that it tends to have problems 1.5 months in. We could try running it. What we'll probably do is try finding a way to speed up parts of the code to see if we can get that issue to occur earlier. But what we'll probably do is start looking at memory. Focus on the code, determining where there might be memory leaks, things like that. It would depend on the situation as to whether we actually try running it for that long, because the code reviews we're describing are more about the source, the readability, whether we think there are going to be problems, the loop timing, things like that. So it would depend on the issue, I think. We might be interested in having it run that long, but really I think we probably prefer to have the customer set up a certain kind of logging on their own so we can learn more about what we're doing. Yes?
Right with your question, I have a application that's got 10 cameras on it. And so just from the get-go, I knew it was going to be a very memory and actually hard drive intensive application. And what I found was that we knew it was crashing, but being that I wasn't on site, we commissioned the system, it was running, and during the initial stages of the project, it was starting and stopping so often we didn't see the problem. Once they got into their normal 24-hour operation, at least once a day I got a report that was crashing. So what we started doing is we stepped back and actually reached out to National Instruments to help me with the troubleshooting process of it. And we started to modularize the code, and we put on a live system some memory mapping. We tracked it through Windows to map the memory of how often is it happening. We found it was very repetitive at 8 hours. And then, like you said, we started modularizing the code down to where, okay, where's the memory leak happening? So I identified it was on memory leak. And then I knew what my system cycle time was, and by modularizing the code, I could strip out the camera function, and was that the problem? And no, it wasn't. So now I can run it, instead of 1 cycle a second, I can run it at 10,000 cycles a second, and take from an 8-hour window down to maybe a 10 or 15 minute test to simulate a 8-hour event. And so,
I'm sorry.
yeah, that's exactly.
Yeah, so when it comes to performance is probably one of the top things you get asked about when it comes to code reviews. My code is not performing at the rate or speed or whatever that I'm looking for. Why? And we tend to come back with not a definitive answer, but you can improve this, you can improve this. They say it's 20% of the code can have 80% of the problems when it comes to performance. The code review, we want to help find that 20% of the code, so when it is time for a customer to make these changes, hopefully they can do it themselves with maybe a little bit of guidance from us, and be able to learn from those experiences. So performance in particular is something we get a lot with these code reviews that we're able to help improve. And the result tends to be, 1, they have better code, 2, they get better at programming in the future, and 3, they figured out what the issue is while doing those things while improving. So there's sort of a compounding benefits to these kinds of code reviews. Yes?
One more thing to that I'd add is that from a developer to developer review process, I know it kind of touches on how small of a project means review. I can't tell you how many times I've learned a better technique, or hey, I didn't know LabVIEW could do that, or I've never thought of doing it that way before by reviewing somebody else's code in the process of trying to help them, or vice versa, them help me. Absolutely.
When you have a language like LabVIEW where any one thing can be done in so many different ways, we tend to have, I know when I started doing these code reviews, I'd have pretty much a similar situation where I'd be doing a review and start writing, hey, you know what, white issue, you did it this way, I do it this way, and then think about it for a minute and realize, you know what the customer did here might even be better. So code reviews are as a means of sort of having a dialogue about programming practices, is there a benefit to one way or the other, can also be very helpful. Any other questions about how we do code reviews? Yes?
Well, a comment about the process. There are a couple of presentations about it later in the week. One is by a former NI employee. One is by a current NI employee. So if you're interested in code reviews, there's more material.
Look forward to those. So I'll tell you what, we're done a little bit early. I know it's lunchtime, I'm hungry. But Kelly and I will stay up here for the next 15 minutes or so if you guys have any questions you want to talk to us one-on-one with. So thank you very much, everyone.